So have you started started week 5 or like no?
Yes, sir. How midway?
Yes, sir.
Okay.
We are started. We started and just I am on tutorials.
Okay. So any problem you are facing? Maybe some questions or
Not in
concepts?
questions, conceptual, sir. In finding domain and range of the composite functions.
Okay, composite ones.
And inverse as well.
Yeah, anything? Okay. So and mostly else. Can see my screen, right?
Yes, sir, we
Yes.
can.
Yeah. So you said you are facing problem in finding the domain.
Domain and range in composite functions.
Yeah. So shall I start from composite function, or you want me to start like revise few things from the beginning itself?
Yes, sir. Revise from few things in the beginning. It will be revision for us.
Yes, sir.
Yes.
Yes, sir.
Okay. Okay, I'll try to revise few things. Okay, let me see how far I can go. Tomorrow also you have a session, right? So so let me see how far I can go. Otherwise, I'll tell Subham to start tomorrow from the place. Basically, I'll stop. Okay, so
Yes, sir.
Sir, in the revision list, sir, can you please also include this greatest integer function and smallest integer function?
Okay,
Okay.
so then better is okay. So it's better to start from the greatest integer function. So
Yeah, from the beginning, sir. Yes.
yeah. So
Yeah.
okay. So what is your problem? Like, see, the thing is you don't understand the definition of greatest integer function, or like something else you are facing the problem.
No, sir. It's actually like when I read, I understand. But if you ask me now, actually, I need to revise it multiple times so that I can keep it. I mean, I
Okay.
should able to memorize it properly, like what exactly it is. When I read,
Okay.
I understand.
Okay, so
But,
okay, so let me start with the definition of one-to-one function, okay, and onto function, and then after I'll define this greatest integer function and smallest integer function, and there we'll check whether these functions are one-to-one or onto or not. Okay.
yes, sir. Yes, sir.
Yeah.
That would be good. Yes.
Sir,
Thank
a
you, sir.
small doubt, sir. Is this about, is this session on week 5 or week 4, sir?
No. This is on week 5.
Oh, okay, sir. Thank you.
Okay, so yeah. So the first thing is your one-to-one function, right? So anyone like you, more or less, you have studied this one-to-one function in week 1 itself. So you want to like, so do anyone wants to say anything about the definition of one-to-one function?
Sir, I think one-to-one function means in the domain, one value maps to only one value in the range.
Yeah. So
Every
this is
input has a specific output.
okay. So again, both the definition in some sense they are incorrect. Okay. So see, so first thing you have to understand what is function. So before going into one function, what first tell me what is okay, I don't know why I'm having this
Sir,
problem.
I think the function definition can be understood like if a value in the domain is only mapped to one value, rather one value in the codomain, rather than being mapped to two values at a time. I mean, the same value in the domain cannot be mapped two times to the two different values in the codomain or range.
Yeah. So in particular, you are saying one input can can take only one output, right? That is what you are saying.
Yes, only
Yeah.
one output. It can take
Yeah.
only one output.
One output. Yeah.
Yeah.
So what basically function basically says, suppose you have a map. Okay. So if you go back and see, you will see the difference between relation and function. Okay. So the only difference between relation and function is basically a function is a relation. Okay. So if you see a function, what is a function? Function is a relation which is not one to many, right? So in some sense, what basically saying, it's what do you mean by not one to many? So this is basically saying a single element cannot go to multiple elements. For example, if I consider this relation, let's say this is a relation from set A to set B. So 1, 2, 3, and I have A, B here. Okay. So the problem is I cannot. So if I take 1 to A and 1 to B, right? And let's say 2 to 1 and 3 to B. Okay. So this is the pictorial representation of the relation. So if I write mathematically, what basically I will get? So I will get 1A, right? 1B, 2A, and 3B, right? So this is the pictorial representation of the relation. So why actually this is certainly this is a relation, okay? Because by definition it's a subset of A cross B. Okay, maybe this is basic for many of you. Still, let me repeat, spend few minutes on this. So this is certainly is a relation, but this is not a function, because as you can see, a function is a relation which is not one to many. So, but here you have a problem here. Basically one goes to A as well as one goes to B, right? So we have in this scenario one to many, right? A single element in my domain, in some sense, in my domain is going to two elements in my codomain, which is not allowed for a function. Okay, so this is the definition of a function. So function is a relation which is not one to many. Okay. So for example, if I consider this one, let's say this one, 1, 2, 3, and A, B, and suppose this is my relation. Okay, this is my relation. So do you think this is so suppose this is a relation, do you think this is a function from A to B?
Yes, sir, it is a function.
Yeah, this is a function from A to B, because we are actually not in this scenario. Okay, if you see, we don't have any element in the domain. Okay, we don't have any element in the domain which maps to more than one element in the codomain, right? So 1 basically maps to A, 2 maps to A. Two different element can go to same element. Okay, two different element can go to same element, but
So you're, are you saying that we can have many to one but not one to many, right?
Correct. So that is what we are ignoring one to many, right? We are not ignoring. So if you see the definition, we are ignoring one to many. We are not ignoring many to one, right? So that is where your one function comes into the picture. Okay, so one function basically says your function cannot be many to one. Okay, I'll come to that. So as you can see, this is a function. So two different elements can go to the same element, right? 1 and 2, they are basically the image of 1 and 2 is going to A. So this is allowed for a function. But as you can see here, a single element is not going to two different elements. which is happening here. Here a single element, 1, is going to two different, it's basically maps to two different elements. This is not allowed. Okay. Whereas this is a function. Okay. So yeah. And let's say, okay, so this is sort of pictorial representation. Let's say I define another thing. Let's say I have a set 1, 2, 3. Not 1, 2, 3. Let's say 1, 2. And let's say this is AB, right? So you consider this relation R, which is, let's say, 1, comma A and 2, comma C. Do you think this is a relation? This is a function. Do you think this is a function from A to B?
No, no, it is not.
Why?
Because
Because we don't have C in B.
Correct. So see, to say that this is a function, first I need to ensure that this is a relation, right? First it should be a relation. Then I will check whether this relation satisfies this condition or not. Then only I can say that this is whether that relation is a function or not. But here, if you see, this is not a real. This R is even not a relation from R A to B, because when I can say that R is a relation, I can say R is a relation if R is a subset of A cross B, right? So you can see this C, whatever I'm writing here, this is not in this set B. Okay, so this R is not a subset of A cross B. So that's why R is not a relation. And since R is not a relation, then clearly I can say that R is not a function. Clear? Okay. So yeah. So the next thing is, once you know what is function, then the immediate types that you study. So basically, you study two types of functions. So the first one is 1-1 function, right? So now, can one of you tell me what is 1-1 function?
Every element of A have one image in B. No
So-
two element have one image in B.
Every input has a specific output.
So
Yes,
that is,
sir.
so that again, like you are basically, see, this is here also every image has a specific output, right? If you consider this one, okay, so this one, you consider this is a function, right?
Yes, sir.
So here also every image has a specific output, right? One has a specific output. What is that? A, right?
Yes, sir. Yes,
Two has a specific output. A.
Okay.
3 has a specific output. B.
Okay, sir.
So do you
Yes.
think this is a 1-1 function?
No, sir.
No, sir.
Why?
No,
Many
sir,
one.
It is a many one.
for
X1,
for 1 to 1,
X1,
it
yeah,
is
X1 should not
required.
be equal to X2,
Exactly.
and f of X1 should not be equal to f of X2.
Yeah. See, when you are saying, okay, every element has a unique output. So what basically you are saying, you are repeating the definition of function. Okay, when you are saying that every element has a unique output, basically what you are doing, you are basically saying your relation is not one to many. Okay, and that is precisely the definition of the function. If the definition of function and definition of 1-1 function is same, then why then we need to give a new name? Okay, so there is a difference. Okay, you try to understand the difference. So basically, what 1-to-1 function is saying, two elements cannot go to the same element, right? That is basically the definition of 1-to-1 function.
Okay,
If
sir.
no if no two elements, okay, in the domain of my function f, okay, if no two elements in the domain of f correspond to the same element.
Or sir, we can say that like different elements of A have different images in B.
Correct. Two different inputs have different outputs. Okay. In the codomain, or you can say range. Okay. F, right? Then you say that your function is 1, 1. So what basically is saying, if you are taking two different input, right? If you are taking two different input, so you have your domain, this is your domain, and this is your codomain. If you are taking two different input, that means you have x1 and x2, and I'm assuming both are different. That means they're different, right? X1 is not equal to x2. Then what basically it's saying, their images are also different. So if I get f of x1 and f of x2, their image, then it's saying both are different, right? So in other words, mathematically, what you can say, for any x1 not equal to x2, if this imply that f of x1 is not equal to f of x2, okay, and for any x1 and x1 is not equal to x2 in your domain, okay, in the domain of function. Okay. If f of x1 is not equal to f of x2, then you say that your function is 1, 1, right? Clear?
Yes, sir.
So
Clear.
for example, if I consider this function, whatever I have written here, so do you think this is a 1, 1 function?
No, sir.
No, sir.
No,
No,
right?
no, sir.
Because the problem is 1 is not equal to 2, right? But f of 1 is same as f of 2, which is problematic. Okay, so this is a function, but this is not a 1, 1 function. Okay, so try to understand the difference between the definition of function, okay, and the definition of 1, 1 function. There is a huge difference. Okay. Okay.
Sir, if f of x1 is equal to f of x2, that means x1 is equal to x2, right? According to one functions.
Yes, that is another way. So as someone said, there is a, so this is a definition. So you can write your one-to-one definition of one-to-one function in this way. If x1 is not equal to x2, then f of x1 is not equal to f of 2. And another way of writing the definition of one-to-one function is basically saying, if f of x1, okay, is equals to f of x2, that means x1 is equals to x2. What basically it's saying, what it's saying, if I have two element x1 and x2, and I have two things f of x1 and f of x2, if f of x1, if these two things are equal, okay, if these two things are equal, then it should imply that these two things are also equal in the domain. Then this implies that your function is 1, 1. So try to think that, okay, so I'll suggest you try to spend some time to see that both these statements are basically same. Okay, what basically it's saying? The first one is saying, if I have two different elements, then their images are same. Okay, and the second one is what basically saying, if image of two elements are same, then both the elements are same. Okay, so they are basically these two statements are same. Okay, you try to spend some time and see why both are same. So
Can you go with any example?
so the thing is, yeah, I'll prove some. I'll take some examples. So in most of the time, actually, you may need this definition, okay, to prove some function is one. Okay, so
Sir, also please, can you please explain if why one to many is irreversible and why one to one is reversible function?
yeah, that I will come. So that is it will come much later. Okay, so
Okay.
So better let me spend some time. Then once I have bijective function, then probably I can go to this irreversible, reversible. Okay, so till now this is clear, right? At least the definition. I'll come to the example. Any doubt from this part?
No, sir.
Okay.
No,
So,
sir.
Sir,
Yeah.
just a minute, sir. I mean, can we use this second method for an algebraic way to prove one-to-one, or I mean, when we'll apply these, which one we should use, the first one or the second one?
That certainly depend on the question. Like it's completely depend on the question, and once you see at the question, then basically it's your.
Okay, suppose if we are given two algebraic functions, like f of x1 is this one, and I mean f of x is this.
Yeah, I'll come to that example. Okay.
Okay.
So okay, so yeah, so let me take few examples for one function. Any example you want me to do? Maybe you can say. Someone already said greatest integer function. I'll come to that. Okay, we apart from greatest and smaller integer, anything?
So any class of function which which are not continuous.
No, you give me a specific example. So you are basically giving a huge class. Okay.
Okay. In one of, I think in the assignment 5, there is, I don't want you to solve the assignment, but there are some, straight line, horizontal lines for, I mean, and then y values are discontinuous for, so that kind of function is possible. Maybe I can think of more, but that for just one such line, right? It
Okay,
has
so okay, so suppose mod is not a line. Okay, certainly it's not a line. So let me start with the easiest one. Okay. So what is this function? What is this one? This is
so what you are telling is every element in domain maps to one element in codomain.
Yes.
Yeah.
What is
That
this
is
one?
So
What?
it is x to the power 0.
Yeah, x to the power 0. Okay, this is a constant function, right?
Yeah.
This is a constant function. What is this function? It's a line, right?
Yeah.
So what is this f of x? F of x is precisely y, right? Y equal to 1. So if I draw this line, so this is what?
Okay.
This
Y is
one,
equal
right?
to- Yeah.
So do you think whether this is a 1-1 function?
It is
Yes, sir.
no, it is not.
It's a coincident line if we draw a horizontal, right?
No, someone said no. Can I?
It passes the vertical line test.
No, it is a function, but it is not a one-to-one because
Yeah, what is your name?
I am Sanjay.
Yeah, Sanjay, whenever I will ask you, you answer. Okay, so you are basically correct, but I don't want you to answer in each and every question. Yeah, so you are correct. So this is not 1-1 function. Okay, so see again, like see, anything you take. So here you have R, right? See you, and here you have R. So whatever you take here, it's basically going to 1, right? You take 0. If you see this function, what is this function? F of x equal to 1 for any value in the domain. So 0 goes to 1, minus 1 also goes to 1, 2 goes to 1. Here you have a pi also in this set, which also goes to 1. So everything, there are a lot of elements in this set, everything they basically maps to 1, right? So this is not 1 1. And this is one of the simplest example of not 1 1 function. Okay, it's a constant function. Everything in your domain, they basically maps to 1. Okay, clear why this is not a 1 1 function?
Yes, sir.
Yeah. So next you come to this question. Let's say you take this function R to R, and what is this function? X goes to mod x. What about this function? Do you think this is 1 1 function?
Not
No,
s-
no, sir.
No, sir.
Yeah, anyone?
Minus one will also give 1 and 1 will also be 1. We will
Yeah.
only get the positive value for every negative and positive ones.
Correct. 2 also goes to 2, minus 2 also goes to. But again, this information, this information is enough for you to tell that this function is not 1 1, because as you can see, I have minus 1 and 1, they both go to 1, right? So this is not a 1 1 function. 1 1 function, right? So again, suppose, let me take this one, f of x. Again, the domain is R to R. Let's say 2x plus 3. Forget about 2x plus 3. Let me take 2x. And of course, I'm taking this as from a map from R to R. Now, what about this function?
Yes, sir.
It is a 1 to 1.
1 to
It is 1 to 1, sir.
This is 1 to 1. Anyone who thinks this is not 1 to 1? Again, if you are thinking that this function is not 1 to 1, then obviously you have to produce 2 elements, okay, in your 2 distinct element in your domain. They basically maps to the same element in the. So this is domain and this is codomain. Okay, so if you can produce, then only you can show that this function is not 1 to 1. Okay, so the question, the thing is, actually this function is 1 1. Okay, as anyone wants to explain why this is 1 to 1?
For minus 1 we will get minus 2, and for plus 1 we will get 2. So they are both
No. See, again,
There is a distinct image.
See, the problem is,
distinct
okay,
image.
see, the problem is, okay, you are actually mixing 2 things. So when actually you are saying the function is not 1 to 1, okay, for example, here you basically said this function is not 1 to 1. To show that this function is not 1 to 1, it is enough if you produce 2 elements that basically maps to the same thing, right?
Yes, sir.
See, by the same logic, whatever you are saying, if I say 2 and 3 are different, and image of 2 and 3 are also different. 2 and 3 are different here. F of 2 is also different from f of 3. Then by the same logic, I can say that this is not, this is 1 to 1. You are basically saying 2 and, so here you are saying 2 and 4 are different, that and their image are also different. I am saying 2 and 3 are here different. F of 2 and f of 3 are also different. Then same, by the same logic, I can say that this is also 1 1. So this is not the correct way to prove a function is 1, 1. See, to prove that this function is not 1 to 1, okay, it's enough for you to provide one example, right? But to prove this function is 1, 1, you have to prove it for all x1 is not equal to x2 for all. Okay, if you go and see the definition, what basically for any x1 and x2 in the domain, this should satisfy. Yeah, so we have to show that for any x1 is not equal to x2, we have to show that f of x1 is not equal to f of x2. See, if I take 2, if you
Sir, can I ask a question?
just a minute, if I say that 2 is not equal to 4 and f of 2 is not equal to f of 4, this is correct. But see, the thing is, I'm not proving for any x1 and x2. I'm just proving it for 2 and 4. There are so many other possible pair for which I'm ignoring, right? So I have to
Yes,
prove
sir.
for any possible x1 and x2. Okay, so to prove something, you have to prove it generally. Okay, you simply cannot produce an example. Yeah, any questions?
Yeah, sir. So how do we check for all the values in the?
Yeah, that I will come. I'll prove it. Yeah.
Sir, does this mean that we graph it and we use the horizontal line?
You
test
can
and-
do that, but the thing is, okay, sometimes it's difficult to graph some function. If you know the graph, then it's certainly easy for you to check whether this function is 1, 1 or not, because you know the rule: vertical line test and horizontal line test for 1. I'll come to that. Okay, so but see, if you know the graph, then basically you know a lot of things about the graph. Okay, so many times you may not know. So for some complicated function, it's difficult for you to draw the graph of that function. So in that case, you are basically stuck.
Sir, if a function is 1 to 1, then it will pass both tests, vertical line test and horizontal line test, right?
Yeah, I'll come to that. Okay.
Oh,
See,
okay, sir.
vertical line test is basically to check whether a relation is function or not. Okay. So if you are considering a function, then automatically it should satisfy the vertical line test, right?
Okay, sir.
Okay. So how then I'll check. See, this is clear, right? So see, what basically I need to prove this statement, right? Question no. Please mute yourself. Okay, so please mute yourself. I'm getting a noise. Mailbox. Okay, so Gopi, can you mute yourself? Gopi, can you mute yourself?
Sir, you have to mute everyone.
Yeah. So suppose
Sir,
you
we were at proving how
Yeah,
for all
yeah.
the values.
Yeah, that is what. Yeah. So you consider any. So what? Certainly, we cannot pick all the possible values. So we have to pick two random values, x and y, right? We have to pick some random value from our domain, okay, such that my x is not equal to y, right? So if x is not equal to y, that means 2x is also not equal to 2y, correct?
Yes.
Yes, sir.
So what is 2x? What is 2x?
2x is the value in the range.
Not 2x, value in the range, correct. So 2x is basically image of x, right?
Yes, sir.
Yes, sir.
And 2x is what? 2y is what? F of y.
Image of y.
Yeah. So in particular, what basically we proved that if x is not equal to y, then f of x is not equal to
Y.
f of 1, right? And that is precisely we wanted to show, right? To show that this function is 1, 1. So this implies my function f is 1. Clear?
Sir, I still have a doubt, sir. Can you take up an expression like you have f of x equal to x, right?
Hmm.
Can you take up some other function and use this theory to disprove that this is not a one-to-one?
Sorry?
We
See,
are,
to-
this
to
is the method,
prove-
right, sir?
See, to prove a function is not 1-to-1, you have to give an example, right? To
Okay,
prove,
can we take the example of x square?
Suppose you consider this example.
So what you mean to say is that we have to first prove it in value for
See,
a
when-
function
when-
and then generalize it to the function value
See,
and
when
say
you
that
are
it's
when you are trying to prove a function is 1-to-1, okay, then only you apply this general method. Okay, when actually you are disproving a function is not 1-to-1, when you are saying that the function is not 1-to-1, then why you will do this method? You will simply you will try to provide an example like this, right? You have two elements in the domain that basically maps to the same element. That is what actually I wanted to say. So you,
right.
when you are taking this example x square,
Sir, but yeah, can I mean, it is not guaranteed that we know the behavior of the given function all the time, right?
yeah,
I mean-
that is obviously you have to guess. Okay, so you don't know, but you have to guess. That is the main. If you know already and you are
Simple
proving,
value substitution cannot always guarantee us, right?
no, that is
That's
not certainly that is not that will never guarantee. Okay, that certainly it's your practice and your experience will tell you, will give you some intuition about that function, and from there itself you can do something. Okay.
So
Okay, sir,
because
thank
in the beginning itself we said that the domain is real number.
Mhm.
So if we consider the end of the real, like 0 to infinity, and then say that these are distinct, so any function in between will be distinct, so and hence it's 1-to-1. Can we
Yeah,
say
yeah,
that?
it's all, see, okay, so that is again something different. Okay, we have
So-
to spend time on that as well. So if I change the domain, if I change the codomain, what will be the behavior?
So you said, let's take one example. So can we take one example like x cube plus x square plus 2?
Okay, that
Can we
also,
take-
yeah, that I have to also check whether, see, again,
Yeah, so
I'll-
because if it is just x square, it's easy to find. But if it is x cube plus x square plus 2, like it is like a polynomial.
okay, it's depend, like if you give me x5 plus a
Yeah.
x square plus 2ax plus 19, even I don't
Yeah,
know,
sir.
I have to check. Okay, so that probably I have to go and check with the Desmos. Okay, because
Oh, okay. So
I
so
even
we will-
cannot, yeah,
So
I
we don't
even
expect. So we should not expect this kind of
yeah, of course, like
in the exam,
again,
right?
yeah, obviously, like see, there are few functions, it's really difficult for you to check whether this function is 1 not. For example,
So-
maybe this
So
one.
what
Sir-
if we consider minus infinity to infinity and then prove
Yeah, which one you were saying?
this x raised to 5 plus 7x squared plus 2x
Ah,
plus 19?
Okay, so probably you have to check the roots. Okay, again, tell me how you are going to do it. Maybe
If
possible.
if we define that the domain is a real number,
Yeah, this, okay, you consider this is a function, okay, from minus infinity to infinity, or basically r to r.
yeah,
Which is valid, yeah.
yeah.
Then,
And then when we prove it for say for minus infinity and then for infinity,
how
what is
you are-
f of x?
How
how
can
you
we
are going to do it? That is what I am asking.
And
I
then
think
plot
what
and
he
the
wants
plot
to say-
and then plot the roots of this function
See,
by
if you can plot it, then basically you are done. To
Maybe,
plot,
sir,
to
yeah,
again,
I think he's
just
trying
let me
to-
complete it. Okay.
Yeah,
So,
sure.
yeah, just a minute. I'll certainly I'll allow you to say. See, the thing is, to plot this, you need to know the roots, right?
yeah, Basically, we need to know the roots where it is intersecting the x-axis.
Yeah, so that is precisely the roots, and finding the roots of this degree 5 polynomial is not easy until unless it's depend if you can if you can do some guesswork. If your guesswork will work, then probably you may find one root. Okay, so otherwise it's really difficult to find the roots of degree 5 polynomial. Okay, so you can't say.
Okay, thank you.
So, but again, like you can, if you draw it in the Desmos, then mostly you can say it. Okay, you just have to apply this horizontal line. Yeah, someone was saying something.
Yeah, I mean to say, sir, if we could alter the codomain, I mean the range, basically, then we might come to a point where the function is either strictly decreasing or strictly increasing. In that way, we can.
See, oneness of a function. Okay, it's basically it's depend on the domain, not on the range. Okay. If you are checking 1, it's
yeah,
completely...
I mean to say domain. Yeah, thank you for correcting me. That's what I want to say actually. Yeah, in that particular, if we alter the domain, then we can find a particular segment of the curve which is either strictly decreasing or
Correct.
strictly increasing.
Correct. Absolutely.
That's what he meant to say. That's what I think.
Absolutely correct. So, so for example, if I again, like I'm making it a lot simpler. Okay, so if I make it, let's say 1 to infinity, okay, from R, then from here I can say that this function is 1. Okay, it's really easy for me to check this function.
Yes, because it is increasing.
Yeah, it's increasing. Okay, so but when I go to minus infinity to infinity, then it's difficult. Okay. At least it's difficult for me at this time. Okay, I am not sure. Probably if I spend more time.
Can I ask a doubt, sir? Sir, if the given function is a even function or an odd function, can we say that it's 1-to-1 or not 1-to-1? This is not an even nor an odd, right? Given expression here. But if it were to be given in a perfectly odd,
this is a even function, then certainly this is not
neither even nor odd, right? The x power 5 plus 7x square.
No, this is neither even nor odd.
Yeah, if it was an odd function, mean all the terms are with odd powers, then we could say something about it. Like it's 1-to-1 or not.
See, if you have a even function, okay, then basically it's not 1-to-1. Okay. But for odd function, you can't say.
Okay.
So for example, odd function. Okay, let me again. I'm actually spending lot of time on this. Okay, so odd function, you take this example x cube, right? This is 1. Okay, right? This is a odd function and this is 1. But if you take this sin x function, this is odd, but this is not 1. Okay. So odd function you can't say. Even function you can say. Okay, so again, like let me come back to here, this function. Okay, so what you can say about this function? From again, obviously I'm taking from R to R. What about this function?
Not 1-to-1. Not 1-to-1.
It's easy, right? Because I just again to show that this function is not 1-to-1, I just have to provide one example, right? And you know this example, -1 and 1, both. And suppose again, as I said, when you are checking 1-to-1 of a function, it's completely depend on this domain, right? Suppose I change this domain, right? I change this domain from, let's say 0. You can include 0. Okay, let me include 0 as well. 0 to infinity to R, and I'm keeping the same function. What about this one?
Now it is 1-to-1.
Now it is 1-to-1 because if I pick any two elements, x not equal to y, right? So then I'll always get x square is equals to y square, because what actually I'm doing here, I'm excluding the negative things, right? So what basically I'm saying, in some sense, so So here x and y are always positive, right? So if x is not equal to y, then
We're just getting the positive squares.
yeah, let's say x is greater than y and greater than equal to 0, right? So this implies basically, again, like there are two cases. Okay, one probably. Okay, so I don't want to complicate the thing. Okay. So I think then you have x square, which is greater than y square, and which is greater than equal to 1. Okay, but if your x and y, they are basically in between 1 to 0, then also, like, okay, x square, yeah, it doesn't matter. Yeah, I was thinking about the square. Yeah, this is correct. Okay, so what basically is saying, if x is not equal to 2, so without loss of generality, we are assuming that x is greater than y. Okay, then we are getting x square is equals to y square. So that means your f of x is greater than f of y. So in particular, f of x is not equal to f of y. Okay. So that's why if I restrict my function on this interval, then my function is injective. Okay, so
Sir, the interval that you have chosen with close bracket and open bracket, it means that 0 is excluded or included.
This is closed bracket. That means
Yeah.
0 is included.
Included. Okay, and infinity is excluded.
Infinity is not a real number, so yeah,
Okay.
you have to
Fine.
exclude.
Thank you.
Concept.
Okay, so this is 1. Let me go back to onto function. Okay. So what is onto function?
Range is equal to codomain.
Yeah, that is correct, but okay. Any other? So you
when
have, okay,
none of
just a
the-
question. So do you have onto function in your week 5?
No, it is only
No, sir.
1 to 1.
It's exponential.
It is
function.
only 1 to 1.
Okay, yeah,
1 to
then-
is defined in first week.
Okay, so onto, okay. So I don't want to go to onto. Onto basically says every element in your, if you have a function from your domain to codomain. So what basically onto function says, every element in your codomain must have a pre-image in your domain. As someone already said, your range should be equals to your codomain. In that case, you say that your function is onto. Okay, I'll not go into this onto. Okay, so before that, let me, someone already in the very beginning, someone asked me this
Integer function. floor
greatest
division.
integer function. Okay, so greatest and smallest integer function. So first you start with this greatest. Greatest integer, okay, function. So what is the definition of greatest integer? Okay, I guess you denote greatest integer like this, right? Probably. Okay, it doesn't matter. What is the definition of greatest integer? Anyone?
Sir, I think it is also known as floor function.
Yeah, let me spend, because floor function, but again, I personally I prefer using this greatest integer function. Yeah.
Is this question to everyone, sir, or?
Yeah, to everyone. Yeah.
Okay. So, greatest integer function, I think, is for any, I'm sorry to say like this, but for any float value in the domain, we'll take the greatest integer of it. I'm so sorry. If anyone.
Yeah, anyone
May I
else?
may I
Yes.
answer that, sir?
Yeah, so the question is, my question is, forget out what is the greatest integer of x? That is what I want to know. What is the greatest definition
Next.
of greatest integer of x? Yeah, please.
Next
May I
is-
answer that?
Hmm. Yeah, please.
So it could be a rational number or anything, right? Whatever is the next.
No,
Integer.
greatest integer is always an integer. Okay.
Yeah, so greatest integer function will convert the domain into a next.
Okay, that
possible
is
integer.
not a definition. Okay, it's even nowhere close to the definition. I'm basically asking what is the greatest integer of x? What is the meaning of this greatest integer of
X minus fractional part of X.
Again, you are basically to define something, you are defining one more thing. Then I will ask what is the fractional part of x?
Sir, I think this is also known as like a jump function or a step function.
Okay,
So,
fine.
that-
Yeah.
That,
any
that means
Let
any
me-
value in the domain
Let me
will
write
take the
the
only integer part of it, I think.
Yeah, you are correct, but see, whatever you are saying, it's correct. I was asking about this one. What is the the definition? So this is precisely the largest integer, that is
Okay, that is beneath the given value. Okay, right.
That
The
is
less, yes.
less than
Now,
or equal to x. Now, does it make sense? This is right. This
Yes,
is
sir.
the definition of greatest integer function. So when I write that the largest integer that is less than or equal to x, for example, if I take 2.3, what is the largest integer which is less than or equal to 2.3? So you have 2.3, right? And you have 3, then you have 4, so on. And here you have 2, and here you have 1, here you have 0, and so on. So this basically says the greatest integer says the largest integer that is less than or equal to x. So which among the following integer which is largest as well as less than or equal to x?
2.
2.
Right.
2.3, it's 2.
So this is 2 is the largest one. Okay, so 2 has a unique property. 2 is the largest integer and 2 is less than or equal to 2.3. What about 3?
It's 3,
3.
sir.
3, because 3 is an integer. So that's why 3 is the largest integer which is less than or equal to 3. Okay, so let me take minus 1.1.
It's
Minus 1.
minus 2, sir.
Minus 1.
Minus 1. Someone said minus 1. Someone said minus 2.
2.
Okay.
Minus
Yeah.
2.
Okay. So
So -2.
yeah, correct. Minus 2. So what actually you where you are in the number line? You are minus 1.1, right? Then you have minus 1. Then you have 0. So then you have minus 2. Then you have minus 3, and so on. So what actually you are searching? You are searching the largest integer that is less than, right? So I have to search the largest integer which is less than this one. See, all the numbers which are on the right of minus 1.1, they're bigger number. Okay, we are actually searching for the largest integer which is less than or equal to x. So this is the largest number which is less than or equal to minus 1.1. Okay, so the answer is minus 2. Correct. And what about minus 3?
Minus 3.
Minus 3.
Minus 3.
Minus 3. Yeah. And similarly, if I say again, like now it's more or less should be clear. What will be the answer?
Minus 4.
Minus 4.
Right. So whoever asks this question, now is it clear the definition at least?
Yes, sir. Thank you.
Okay. So so once we have this, the next question is how we can draw the graph. Okay. So, okay, so before going to the graph, okay, so now we have a function, right? So this is a function. This is well defined for all the reals, right? So I can consider this as a function from R to R, right? I can define this as a x goes to the floor of x or the greatest integer function. Okay. So my question is whether this function is 1, 1.
It's not.
Why?
Because for 2 it will give
For-
2, and for
Can you repeat the
2.3
question?
it is also give 2.
Sorry. Yeah, you are correct. Yeah. So I am asking actually whether this function is 1, 1. Okay, that was the question.
No, this is not
Yeah.
1 to 1.
No,
So-
sir, it's not 1-to-1 actually.
So for example, as you already know, if I take 2 maps to 2, right? And if
Right, sir.
if I take 2.3, this also maps to greatest integer of 2.3, which is 2, right? So
Right.
this is not 1-to-1, and similarly you can get lot of possible pairs, right? Like this. Okay, so the next question is how I can draw the graph. Okay, I somehow I know more or less I have some idea about the values of the function. Then how I can draw the graph? So
Sir, domain is real numbers.
yeah, domain. Okay, domain is real, but again, you can restrict to some. Certainly, we can't draw. Okay, but yeah, you consider the domain to be real. But we'll draw first few values: 0 to 1, 1 to 2, 2 to 3. Let's say, and here you take 0 to -1, 0 to -2. Sorry, -2, and that's all. Yeah. So in this region, actually, we want to do. Okay, the graph. So what is the value of the function at 0?
0.
0.
0.
So if I take any number, which is greater than 0 and less than 1, what is the greatest integer of that
0.
number?
0.
0, right? So my graph, if you see, my graph will come to here. This 1 is not included. Okay, I have drawn maybe in this color, whatever this color is. Maybe.
Vertical asymptote. Yeah.
Yeah.
1 is not.
Yeah, so 1 is not included. Okay. So next, if I take, let's say, if I take any number, let's say if I take any number which is greater than 1, greater than or equal to 1, and less than 2, what is the greatest integer of that number?
1.
1.
1, right? So then, let's say I have 1 here, then I will get a 1. So this 2 is not included. So here 1 is not included. Okay. And similarly, you can see for in 2 to 3, you will get 1, and this 3 is not included. You will get the image of 3 is basically 3 somewhere here. Okay, this is just a point. Right. And what about this one? If my x is greater than 0 and less than equal to -1, right? What is the greatest integer of x?
-1.
-1.
So probably I will get it here, right? So
Sir, isn't it x lesser than 0?
correct. Yeah, so this, now you can see the difference. So here now this part is not included. Okay, see this 0 part is not included. This part is included. Okay, this is your -1. And let's go back to -2. And similarly, you can see that if you have a number in between -1 to 2, then
-1 greater than x.
you will get this one. Okay. This part is not included. Okay. So clear the graph and the definition of greatest integer function.
Yes, sir.
So let me come back to this another one again. Like once you know the greatest integer, then you have this smallest, which probably we call it as ceiling of x. Okay. So smallest integer function. Okay. So again, my question is again, I want to ask what is the definition? Okay. What is the definition of this smallest integer of x?
The smallest integer above x is taken as the smallest integer greater than x is
greater than or equal to x.
Greater than or equal to x.
Correct. Integer. See, the thing is actually you should you should actually able to differentiate between you should able to differentiate both the definition. Okay, so why actually so here you have a greatest, right? Here you have a greatest. So in the definition, obviously you will get some largest integer. So now the question is, if I say the largest integer, suppose if I change this definition, the largest integer that is greater than or equal to x. Okay, so if I slightly modify the definition, if I say the largest integer which is greater than or equal to 2, which is that integer? The largest integer.
Infinity.
You don't have the integer, right? Infinity is not
Yes.
integer, so you will not get an integer. Okay, so that's why if I change this one to the largest integer that is greater than or equal to x, then that doesn't make any sense. Okay, so I can't do that here. Okay,
You
so
mean to say it's unbounded, sir? If we change
yeah,
that
the
definition?
largest, there is no largest integer which is greater than or equal to x, right? Because
It's
I have
unbounded.
3, I have 3, I have 4, I have 5. If you pick 4, then you have another integer 5. If you pick 5, then you have one more integer which is greater than 5, 6.
Understood, sir.
So this is unbounded. Okay, you will not get a number, okay, which satisfy this property. Okay, so that's why. But if you put this one less than or equal to, then you can see you have a unique number, right? You have a unique number. Similarly, here also, if instead of greater, if I write less than or equal to, then I will not get a unique number. Okay. Okay, so the definition says smallest integer that is greater than or equal to x. So let me start with again 2.1.
Three.
3, right? Because you have 2.1, you have 3, 4, and so on. You have 2, you have 1. and so on. So what you want? You want a smallest integer which is greater than or equal to x. That means you want a smallest integer which is greater than or equal to 2.1. Right? You have 2.1 and you want a smallest integer which is greater than. So this is the obvious candidate. Okay. 3. And if I take 2, then what I will get?
2.
Also 3, right? And let's say you have minus 1.1 again.
You also mentioned in the definition or equal to x, right?
So, this is 2. Correct. Yeah, it's a mistake. It's 2 because greater than or equal to, as you have already pointed. So what about this one? Minus 1.1?
1. 0.
Minus 1.
0.
Oh,
0.
0, sorry. Yeah, 0.
0?
Yes, sir.
Greater than.
No, minus 1. Sorry.
Minus 1.
Yeah, minus 1. Sorry.
See, you have minus 1.1, right? You have minus 1. Then you have 0.
Minus 2.
You have minus 2. So you see, minus 2 is not a correct candidate, right? Because you want a number which is greater than minus 1.1, but minus 2 is not greater, right?
It is smaller.
Minus 1 is greater and is basically it's the smallest among all the greater. Okay, so that's why this is minus 1. And again, like the same logic, if you consider minus 1, you will get minus 1, right? Whether this part is clear as well, or do you want me to take few more examples?
Clear,
So
sir.
it's clear.
Yeah. So again, you can draw the again one more thing. The same argument. This is not 1 to 1. And similarly, draw the graph. Okay. Try to draw the graph as well. Okay. So okay. So before moving into some other thing, let me just you mostly all of you know this horizontal line test. What basically it says, suppose you have a graph. Suppose you have a graph like this. Okay. And if I draw a horizontal line, so if the horizontal line touches the graph at more than 1 point, okay, then whatever the function for which you have drawn the graph, that function is not injected. Okay. So what basically I'm saying, if you have a graph of a function, and if somehow if you are getting a horizontal line which cuts the graph at more than 1 point, then the function is not 1, because why? Because you have a point here x and you have another point y, right? And clearly x is not equal to y because they basically represent two different points on the number line. Okay, and each points in the number line, they are unique. So x is not equal to y, but if you see image, right, this is, so you have x and something, right? So this something is nothing but it's the image of x, and here also you have x and something, and this something is nothing but f of y, and in this line your y is constant, right? You are not changing the value of y. That means your f of x and f of y, they are same. So what actually you are showing by this horizontal test, if this line cuts the graph at 2 points, what basically you are showing, you have 2 points, x is not equal to y, but your f of x is equals to f of y, which basically contradicts the definition of 1. So in that case, your function is not 1. Clear?
Yes, sir.
Okay, so the next thing, what you want me to discuss, or you have any question?
Sir, can we discuss inverse functions and
Okay.
graph?
Sir, can I bring back your attention to the equation that was provided as x raised to 5 plus 7x square, that equation.
Mhm.
So in that we had already said, if the domain is minus infinity to infinity. So in this function we have one x square factor. So this relates to that
square
within this
factor.
domain this will be not 1-to-1.
X square factor. How?
So because x square will lead to the parabola curve for the domain minus infinity
This
to
is not
infinity.
parabola. You have a x5 here.
But plus 7x square, that x square roots will have two distinct roots, or
We don't create graph like this.
okay.
How you are going to create a graph? If you have only this term, then only you can. So you can't see. Then you create a graph of this one. Then you create a graph of this one. Then you create a graph of this one. Then so this is not how you draw the graphs, right? Okay. Yeah.
And
If
it
you-
is not a one-to-one function, sir. I check it in
create that way,
Desmos.
I have like, if you create that way, if you create the graph of individual terms, how would you add or subtract whatever the sign is? How would you do that?
Right. So I got your point. Thank you.
No, you can add.
We cannot add the graph of different.
Certainly, there is
same
no
function.
meaning of addition of graph. What basically I want to basically say, you
What perhaps what you are suggesting, sir, that you are suggesting that how we can add it algebraically. My point is how you can add it graphically.
no, you can't add graphically, right?
This is what I was. This is
Yeah,
what I
there
was.
is there is no concept of addition graphically. Okay, so
This is what I was suggesting.
yeah. So
Sir, sir, if we find its derivative and for random
that is
value,
that is a different thing. Okay, I am not going into derivative. Okay, there are lot of ways of checking. Maybe in some sense drawing the graph of this function.
Sir, I have a general doubt. Can I ask? Yeah. When will we discussing the activity question, sir?
We don't.
Can we discuss it now, or
so initially, actually, I have asked whether you have any doubt. Okay, so nobody actually asked me any doubt. So that's why I started discussing.
Okay. I thought this was reserved for conceptual questions.
No. Initially, as I said, like I asked in the very beginning, so nobody asked anything. And that's why I started.
Okay, thank you.
So if you have any question, then probably I can. If many of you have questions from activity, then I can start explaining now itself.
Okay. I mean, I'm in the middle of them. Once I complete, I can ask actually.
So,
thank you, sir.
So is there any difference in the function increasing or decreasing, and the function strictly increasing and decreasing?
There is difference. There is difference.
Is there any difference in both, or both are same?
No, they are not same. Okay, so let me just explain you. Try to explain you by some examples. Okay. So before that, let me tell me what is the definition of strictly increasing.
No, so actually, strictly increasing. I'm unable to understand the definition of strictly increasing.
You tell me the definition. Forget about understanding. You tell me the definition.
So actually, I understand.
Then I will not explain. You first try to remember the definition. What basically it's saying. Okay, you are not able to tell me the definition. How if you don't know the definition itself, how you are going to understand it? I'm simply asking you what is the definition of strictly increasing. I understand you have problem, but at least you should be able to tell me the definition, right? What basically it's saying.
So, but actually, in the course, when sir told, sir teach us, then I think there is no any place where he teaches us the definition of strictly increasing or decreasing. That's why.
Is it whether sir didn't
in the-
discuss about strictly increasing function in the lecture? I guess he has covered this strictly increasing function.
Yeah, actually, I have completed only 5 lectures of starting of V5. So it's maybe in the.
No, as far as I know, maybe he has covered it in
Okay,
lecture
so then
2 and 3. Okay,
definitely.
I'll see again, like, so it's not to you, it's more or less to all of you. So whenever you are asking something, you should at least tell me the definition. Okay. See,
Yeah,
once you remember the definition, then only you can, the next step is you should try to understand the definition. If you don't know the definition, then suddenly you can't understand the definition.
Yeah, that's fine.
Yeah.
Sir, I
Okay.
have
Sir, can I ask something?
Mhm.
I just want to know the meaning of invertible. What is the
Mhm.
meaning of invertible? What is, I'm not able to get that word.
Okay. So, yeah. So suppose you have a function. Okay. So
Okay.
okay, so suppose you have a function. Right? Let's say R to R. X square, right?
Okay.
So what I want, so this function is not 1, right?
Yes, this is not 1-to-1.
Because you have this, right?
Yeah.
So
This is not onto either.
Onto either. So let me first, okay. If you want, let me make it a onto function.
Okay.
So now this is onto. Okay. So what is the idea of invertibility? Okay. So I want a map from the other side.
kind of like reversibility.
But yeah, you are correct, but I was drawing it badly. Right? I want a function. Okay. So I want a function with some property. Okay, that I will come later. Okay, so the problem is, so here actually, what is the problem? So for 1-to-1, if I try to define a function, then what actually I'm basically in a trouble, right? Because -1 is going to 1, right? And 1 is also going to 1, right? So if somehow, okay, I don't know. So okay, there is a way, but if there is a way with some property. If I want to find an inverse function, let's say sorry, not inverse function. If I want to define a function from this opposite direction, then this function should satisfy this property, right? 1 goes to -1 and 1 also goes to 1, right? But this is not a function, right?
Yes, and I heard, I'm not sure, but 0 to infinity is lower, so it can be domain of that R, right?
Which one?
If you just opposite that thing, then R the domain, R is domain and range is 0 to infinity. But opposite is not possible. 0 to infinity can't be domain if R is the range, right?
So that is what I'm saying. See, since this function is not 1, 1, okay. if I try to define a function from this opposite direction, then basically I will end up in this situation.
Yes, that's the
So this is not a function itself.
function, right? Got it.
Not a function. So that is one of the reason when actually we are talking about invertible function, we are ignoring this, ignoring all the functions which are not one-to-one, right? Because if we have function which is not one-to-one, then we'll face this problem, whatever problem we are facing here. Okay, so when we'll define a function from the reverse direction, then basically we'll end up with a relation which is not a function, right?
So, sir, can we say that all one-to-one functions are reversible? Invertible, yes.
Yeah, you can say that, but again, there is some condition. You have to consider the range, okay, not the whole codomain. Okay, I'll come to that. Just give me a minute. Okay, so now you consider the class of one function. Okay, now we are only concerned about the class of
Yes, तो तुम लोग क्या कर रहे थे ये बताओ जरा.
Please mute yourself.
Sorry.
Yeah. So in the class of invertible function, what basically, suppose you have a map. Suppose you have a map. A to B, and for the, again, like, assume that this map is onto as well. Okay. If it is not onto, then you can actually restrict to this, you can slightly restrict your codomain, right? So for the sake of simplicity, you assume that this map is onto. Okay, so if F is a function from A to B, then what is the inverse? Then the inverse is a map from B to A, okay, such that F compose F inverse is your what? Is your what? It's your, anyone?
Identity.
Correct. Yeah. Your identity function. Okay. So what is identity? So basically, what basically it's saying? F compose sub X is I of X, and identity function is basically I of X is X for all X in where?
That means this is invertible, this kind of function.
Yeah, so if F is a function, then I'm defining the inverse. Okay, what basically I mean by inverse? Okay, inverse is a function, right? So this is if F is on 2, okay, 1 and on 2, then you have a map F inverse from B to A which satisfy this condition. Okay, so this inverse function is unique up to this conditions. Okay, so the first one is this, right? F compose F inverse is identity. So basically identity function is what? Your I of X is X, right? So what actually I'm trying to say here, what is, so when I'm writing this, where this X belongs? where this x belongs. See what is this? If I expand
Function
this,
of x.
what is this? F of
F,
again.
f of x, and again that's f of x.
Yeah.
F of x.
Again,
F
to understand this, you need to understand the composition. Okay.
Yes.
So I'm writing what? F inverse of x. Right?
Yes.
When this is possible? When this is possible?
When the range of
No.
if
When x is inside B. Right?
Yes, sir. When we
See what was my question? So what basically I asked you where, so I wanted you to answer this part, right? Where this x belongs, right? So that is what. So see, when I'm writing f compose f inverse of x, that means this is precisely same as f of f inverse of x. And when I can write this as f inverse of x, precisely when my x is inside this domain of f inverse, which is B.
B.
Yeah. So the second condition is f inverse compose f is also identity. See, you have to differentiate the situation. Here the identity map, it's a map from B to B. Okay. See, F inverse is what? F inverse is taking B to A, right? And
Right, sir.
F is taking A to B.
A to B.
So when you are composing F inverse, when you are composing F compose F inverse, it's basically taking what? B to B. B to B.
B to B.
So here this identity map is a map from B to B, right? So the next condition is F inverse compose F is identity, right? So that precisely means F inverse compose F of X is
equal to
I of X, which is
I
X.
of X or X.
It's
here,
a converse.
Yeah.
A to A map.
Yeah. So that means X is, so here X is inside
A,
right? So F inverse, actually, again, I'm actually not saying anything, not explicitly giving you the expression of F. I'm just defining what is F inverse. Okay. If you have a function which is 1, 1 and on 2, okay, then F inverse it's nothing but it's a map from B to A with these two properties. So this part is clear. So now you tell me, so if F is a map from A to B, so what is the domain of F? What is the domain? Domain of F inverse. You know domain of F, suppose. Okay. You know domain of F and domain of range of F. What is domain of F inverse?
It's the range of F.
Correct. It's the range of. So if you know everything about F, okay, then the information about the domain and range actually for F inverse comes free. Okay, you don't have to do compute it explicitly. So this is one thing. Domain of F inverse is same as range of F, and one more thing, range of F inverse
becomes the domain of F.
Domain of F, right? So before going into some maybe say some x square, maybe x q, x 5 or something, just simply concentrate on some simple function. Okay, so this is my A. Okay, 1, 2, 3, and this is my B, A, B, C. So if I consider this function, then it's completely nonsense, right? I can't talk about the inverse, right? Because this function is not 1, 1.
Yes, sir.
Right? So I have to consider it in some sense. It's a, as I said, I'm considering 1, 1 as well as onto, but I'll come to that. If this is not onto, you can also do that, but with some extra assumption, not assumption, extra restriction. Okay.
Inverse is possible in 1, 1 function.
Yeah, possible, but again, you can't directly do it. Okay. So now you suppose you consider a bijective function. 1 goes to B.
Sir, a small doubt in that point. For invertibility, it is necessary to be bijective, or even an injective function also can work to have
now I'm only concerned about bijective function. Okay, I'll come to that. It's possible for injective function as well, but again, as I said, with some extra restriction. Okay.
It's not necessary.
Yeah. So this is a bijective function. You agree?
Yes, sir.
Yes, sir. This is bijective.
So this is my f,
bijective.
Right? This is my f. And what I want a f inverse, right?
Yes.
I want a f inverse which satisfy these two conditions, right? These two conditions, right? So my f inverse is precisely, it's a map from
B to A.
B to
E.
A, right? So this is my f, right? And this is my
F inverse.
F inverse.
F inverse. I want a map from
B to A.
B to A. Not any map, right? Yeah, if I consider this map, let's say if I consider my F inverse is this map. Okay. So do you think this F, okay, instead of writing this as F inverse, okay, let me write it as F inverse. So what I want to say, I cannot take any map, right? Any map from B to A. My F inverse should satisfy these two conditions, right?
The mapping should be same.
Right? It should satisfy these two conditions, correct? So do you think this F inverse will satisfy the condition? For example,
range domain are same. This condition satisfied.
But okay, this is not a condition. Okay, this is not any condition. See, F inverse should be a map from.
How do I find that is the
yeah, it should satisfy these two conditions. So what basically it's saying, F inverse compose A should be an identity function on what? On
A.
On A, right? Okay, let's check whether this is an identity function on A or not. It's easy. It's really easy to check. Okay, so for example, let's check what is F inverse. This is what we want to check, right? Whether this is an identity function or on A. So let me start with the element of A, 1.
One is mapped with B.
1 is mapped to B.
But B here mapped to 2, so it is not satisfied.
1 to okay. F of 1 is what? F of 1 is B, right?
B.
What is F inverse of B?
2.
2.
So this is not going. This is not matching.
It's 2, right?
Hmm.
So this is not possible.
Match now.
See okay, can you see there is a huge problem the way we have defined it? Okay. The way we have defined A inverse, if you simply see it, then from there itself you can say that there is a huge problem in the definition. Why? See, here if you see 2, actually it's going to A, right? Here 2 is going to A. right? So that's why A should come back to 2, right?
Yes, but if it is going to 1, so
It's going to 1. So it's a really terrible
breaking
way
the
to
law.
define F inverse. Okay. So 2 is going to A means A should come back to 2. Okay. That is the main
in the
idea.
inverse.
Yeah, that is the main idea of this this inverse. Okay.
Even the converse is also true, right, sir?
Yes.
So if we go to 1, then we have to come back to 1, like
yes.
F
That
of
is that.
F inverse.
Correct. Absolutely correct. So since 2 is going to A should come to 2, right? 1 is going to B, then B should go to 1 in F inverse. 3 is going to C, and
So C has to go to 3.
now if I check, okay, I don't know why I removed that. Okay, so F inverse of A. Now I want to check. So now you check this one. Now I have defined this function. Now you check for this one. Okay. What is F of A? F of A is what?
F of A is 1 and
B.
F
of 1 is B.
B and B is 1.
1. Similarly, you can check for 2. You will get 2. Okay. You can check for 3. So this is the first one. What is the next one? F compose. I have checked F inverse compose F, right? I have one more condition. F compose F inverse should be an identity function on B, right?
Yes.
Yes, sir.
So again, if I check similarly, F compose F inverse, then let's pick. So here it's an identity function on B. So let's pick A.
A go to 2.
What is F inverse of A? F inverse basically it's a map where A takes
2.
And what is F of 2?
A.
Correct. It's an identity function. Similarly, you can check for B as well as C. Right. So this is actually the whole idea of inverse. Okay. What inverse is basically saying? So here you have a function which takes 1 to F, and in the opposite side you have a function which basically takes this one to the B. Okay. That's why actually we are facing problem when we are trying to define this inverse of this 1, 1 function, because we can't do that, right? So so here I have 1 and here I have 2 things. Okay, I can't come to a unique things. That is the problem with this function which are not 1, 1. So this part is clear.
Yes, sir. I just want to ask one thing. If you say that if this is not onto, then we restrict to make it onto. Okay.
Yeah.
And if we restrict to make it onto, then it can't be invertible.
Just a minute. Okay. Yeah, I got your point. Okay. So what actually you are doing? So suppose you have a function like this. Okay. Suppose, so when actually I have written here range of F. Okay. Range of F. So here actually it's vacuously it's B, right? Because I'm assuming my function is onto, right? So it's vacuously it's B, right? So, but okay, so so there as in the very beginning I said, right, I can define for a 1, 1 function which is even not onto, right? So in that case you have a difference, right? This range of F and as well as this B, right? If this function is not onto, okay, then there is a difference, right? Okay, maybe I'm confusing you. Let me.
Yeah, I'm not able to get it.
Yeah, let me write it. Let me first explain this with an example. Suppose the same thing, whatever I have written, you have 1, 2, 3. You have A, B, C, D, where 1 goes to B, 2 goes to A, 3 goes to D. This is a 1, 1 function, right?
Yes. Right.
This is
1 only.
This is 1. Now, if you tell me, can I define a invertible function? Okay. Can I define a invertible function from this one, A, B, C, D,
No, can't be.
to
Is not, yes, I think we can, because C is not mapping to anything. But that will not be function.
yeah, that is what I am saying. Right? That is what I'm saying. See, if you define, actually the problem is there is no obvious choice for this C. Right? If you see,
Yeah.
there is no pre-image of C. Okay. So what, instead of what we'll do, so now there is a slight problem. So we have to restrict the domain of F inverse. So we can't take the domain of F inverse. Okay. We can't take the domain of F inverse to be this whole ABCD. Right.
Right.
What will, instead of that, what we'll do, we'll simply consider the image of F, right? And what is that? This is A, B, D. Got it?
That means every time the codomain and range has to be same.
To be adjusted. Yeah.
Not same. If it is not same, then you have to adjust it. Okay.
That's
So
what I'm
here,
saying. Then by adjusting, we have to do that. Then only we can transfer. We can invert it.
get a invertible function. Okay. You have to, if your domain and range, if they matches, then basically you are in the best condition. Okay. If they don't match, then you have to make an adjustment. So in this case, how I can define my F inverse? Now my F inverse is basically, it's a map from where? It's a map from
A to B or
A, B,
D.
Right.
D.
And what
Right.
is the now you can see right here when I'm saying the domain of F inverse is what? Is the range of F, right? And now you can see the difference, right? Here, when I wrote that domain of F inverse, it's same as range of F. Okay, in this case. So there is no difference, right? Basically, I was getting B here, right?
Yes. Yes.
Right, because in the very beginning itself, I assumed that my function is onto, right? But here, this is, if I consider this A and this is B, right? Here I will not get B, right? This range of F is not equal to B, right? It's a subset of B, right? So now we are actually in two different conditions. Okay. So that's why if you assume your function is onto, okay, which eventually we are doing, right? We are actually restricting this codomain
to make it onto,
right? So that is what we are doing. So, and then we have 1, 2, 3, right?
So that's how we make a one-to-one function a bijective kind. Correct.
Then bijective is the perfect scenario to make a function invertible.
Correct. This is if this is 1, 1 and as well as onto. Okay, this is the perfect scenario. Otherwise, if this is not onto, then you have to restrict your codomain so that you will get. You have to basically consider your range as your codomain. Okay. So then you will take. You will take A to A will basically go to what? 2. B will go to 1 and D.
3 will go to D.
So if you consider this as your F inverse, then you can check that F inverse is the identity function. Okay, on which set? It's identity function on this set, right? A, B, D.
Yes.
Right, and F inverse compose F. It's a identity function on this set A. Okay. Yeah, Abhishek, what is your doubt?
Sir, I have a doubt in composite functions domain and finding domain and range.
Yes. I basically I was discussing. Okay, so I to actually to discuss this inverse function, you need composition function, because this is how you define your to define.
Yes, sir, I understand this inverse function. I will.
Okay, I'll come to the, okay. You probably you
Okay.
have some question.
I'll wait. I will wait, sir.
Okay. Any now till now whatever I have discussed, is there any
Yes,
doubt?
sir. No, sir. I understood inverse function.
I'll come to your question now. Just
Okay.
give me some minutes.
No problem, sir.
Yeah.
No problem.
So okay. Any doubt till now?
No, sir.
No doubt, sir.
Okay.
No
So
Now
do you,
clear.
Understood.
That
you
much
want,
that much is clear.
okay. Anything else you want me to discuss about this inverse function? Because again,
No, but then I have to do the math to make it more understand. Then I will
you
ask.
try to solve questions. Okay. So,
Yeah, now I'm going to try to solve question because I didn't get it. I don't know how to do these things. That's why.
mhm. Okay. So
Sir, I have doubt in activity question.
what is that?
Activity 5, question number 4.
Is it related to inverse function? Hello? Is it related to
No,
inverse?
it's not related to inverse
Okay, then I'll do it later. Okay. Okay, just let me do a question. Okay, so probably I don't know. It's mostly you have seen it one of the tutorial, but not sure whether you have seen it. You take this function. Okay. Okay, sir. This is x square plus 1. Probably it's there in your tutorial.
Okay.
Right? So this is a function, 1 function. Do you agree? Because I'm taking, so this,
Yes, this is one.
This is what? This is precisely 0 to infinity. Okay. And here also 0 to infinity. So this is 1, right? So 1 is fine. Okay. What about onto? Do you think this function is onto?
No, I don't think this is onto because the x square is there, no? So always it will the return will be positive. Oh, 0 to infinity. Okay, there's no R to R. This is the onto.
No, again also you are so initially I said I thought you
0 to infinity is 0 plus 1. I thought this is onto. I didn't
see
get it.
x square is what? It's always greater than or equal to 0, right?
Right.
Then x square plus
This
1.
plus 1 is always 1 greater than this.
Right. So
right.
that means what is the image of this function? What is the image of this function?
If there is 0, then that is 1. If 1, that is 2.
So the domain is
Yes.
real.
1 to infinity.
This is
It
the
will never come never come to 0.
this is the image, right?
Yes.
This is
Got
the
it.
image of f. And this is the codomain of f, right? So do you think this function is onto?
No.
Clearly, this is not this function is not.
No, not
right?
on.
Yeah, actually, someone asked me about the real. See, sorry, about the domain. See, domain is R, but again, we are not considering this function from R to 0. We are actually restricting our function because we see if you consider this function from R to R, okay, in that case, your function is not 1, right? If your function is not 1, then we can't talk about its inverse. Okay, so that's why.
A small, I mean, in continuation with that, you're saying that this is not a onto function, but in the codomain, we have an open bracket, right? Means an exclusive one, not necessarily with it. So the given one inclusive bracket 1 comma infinity, it is satisfying the range, right? I mean, the range is
What is
satisfying
the pre-image of 0.1? 0.1 is inside this set, right?
Oh, right. Now it may, yeah, got it. Okay.
So
yeah.
this is
Now
not
I
on
understand.
to, right? So if
Okay.
it is not
Right.
on to, then what we have to do? We have to find a inverse, we have to restrict the what? We have to restrict the what? We have to restrict the
Codomain. Yeah.
codomain. So we have to take the range, right? Now we are in basically in the best scenario. Okay, this is both 1, 1. I guess okay. I guess yeah, I made a mistake. So whether it's confusing you, whatever changes I have made. Okay, so both 1, 1 and non 2, right? Any problem till now?
No, sir.
Yeah. So now this is F. So then F inverse. What? F inverse will be, so this function, since this is both 1, 1, this has a inverse, I know. And this will, the S in F inverse will be a map from this one to this one, correct? So, right? So this F inverse is a map from this to this. So now it should satisfy this condition, right? What is that condition? This should be equals to identity on this set, right? That means my F compose F inverse of X, right? It is identity of this of X, which is X, right? So that means this should satisfy for all X in this interval. New page. So, right. So that means F of F inverse of X should be equals to X for all X, right? So for our, to make this calculation much more easier, let's denote this F inverse X as Y, right? So then I can write this F inverse of X, which is nothing but it's Y. I am just simply denoting this as Y, as X, right? What is F of Y now? What is F of Y? You know the value of F of X. What is now F of Y?
X square plus 1.
F of Y is Y square plus 1. Okay.
Yes, y square
Yeah,
plus
y
1.
square plus 1.
Y square plus 1, right? That means Y square is nothing but X minus 1. That means Y is nothing but correct, right?
Yes.
Yes, sir.
Right. So now we have two possible choices from this. Basically, we are getting two possible choices for F inverse of X, right? Now your next task is to check which of the following satisfy.
It's the identity.
your identity that F compose F inverse is I of X.
Then we have to check the range of the f functions, right, sir?
No, you don't have to check anything else. You just, because this range does its range is always, it's going to be this one. Okay.
Okay, so okay.
Correct. Even yeah, so you are correct.
Because we get
yeah.
+1 and -1.
Yeah, you are absolutely correct. Okay. So what actually he is saying, if I consider this function, let's say if I consider this function, right, I'm in trouble. Do you know why?
Because it is not in the range of f function.
So my F inverse is a function from 1 comma infinity to 0 comma infinity, right? So if I consider this one, then it will give me negative value, right? Negative values. So this is not possible. So you are basically left with one more option, okay, which is x minus 1. And for this function, you can check actually this satisfy both the conditions. Okay, F compose F inverse and as well as F inverse compose F. This will give you the identity. Clear for this problem?
Yes, sir.
Okay.
Now can I ask doubt, sir?
Someone asked me about some composition thing. He asked me a lot.
Yes, sir, it is me, Abhishek.
Yeah. So,
sir, so if you explain me an example in which I have doubt, fx is equal to 2 by x minus 1.
This is precisely the example that sir
has
done.
And g of x is equal to 3 by x. So, sir, if in question we have to find domain of f of g and f of g of x. So I find the f of g of x, but I have trouble in finding the domain of f of g.
So okay, so how first okay, so when you are computing the domain of F compose G, okay, so there are few rules, right? You need to exclude some of the input, right?
Yes,
which sir actually mentioned. So what is the first one? So the domain should not contain, if X is not inside the domain of G, that means X also should not be inside domain of, domain of F compose G as well, right?
Okay.
And the second thing is, you consider all the X such that G of X is not inside the domain of F. Okay. So this set must not be inside domain of F compose. So what actually this first is clear, right?
Yes, sir. We can't put 0 in G function. X is equal to 0.
You can't put 0 inside the domain of F compose. Okay.
Yes, sir.
So what actually you are doing when you are composing when you are composing two things? What actually you are doing? So F compose G, right? So this is your G. This is your G, right? And this is your
sir.
F. Suppose G goes to, let's say, 1, right?
Yes, sir.
And 1, suppose it goes to 1 and 1 is not inside the domain of F. 1 is not inside the domain of F. Then if I write this,
Yes, sir.
then this has no meaning, right? F
Yes,
of
sir.
1, right? This has no meaning because 1 is not inside the domain of F. Okay.
And
That
we
is-
can't predict the pre-image of this.
there is no value for 1, okay, with
Okay, sir.
respect to this. So that is what we are doing here. Can you see now? So we are cutting out all the x so that g of x is not inside the domain of
F.
right? So we are cutting out these two sets. I am not sure, maybe in some of the example that is actually sort of point of confusion. In some of the examples he is also removing the points which are also not inside the domain of F as well. Okay, that I'm not sure, I have to check. If x is not inside domain of F, then also you cannot take. Okay, I guess he's doing in one of the examples. Okay.
Sir, in lecture, sir explained the 2 points you written in red points.
Correct. But if you see one of his example, I'm not sure, but as far as I remember, in one of the example, even he is considering this one. Okay.
Okay.
So I'll check and let you know in which example. I don't remember now. Okay, but for this problem, okay, let's
But
consider.
sir, in the activity question, the thing you are talking, right, domain of F. So in one of the activity question, the similar kind of question is there, and in that the answer doesn't contain that domain of F. Yeah.
As far as I remember, there is some confusion with this question. So I'm not sure, but in the exam, okay, most likely I'll make sure that this sort of question don't come in the exam. Okay, and if it is coming, okay, then you should consider all the 3 points. Okay, and mostly I'll make sure that this sort of question will not come in the exam. Okay, because as someone already said, actually in his lecture, actually he's specifically taking these 2 cases, and I'm sure in one of his example even he is considering this case as well. Okay, so when in activity question, when you are solving the questions, okay, you consider these 3 cases. Okay, this one, and this one. Okay.
But sir, when I took all the 3 cases, that time my answer went wrong.
Okay, I'll come to that.
Maybe I will put that question in discourse, then you can answer that.
Yes,
I'll tag
please.
you.
Yeah, sure.
Sir, can you write the 3rd point clearly so we can write down?
It's there in the lecture. If you see, probably you can new page after. Okay. So,
sir, can I ask a different doubt?
Just a minute. If X is not inside the domain of F, then also X is not inside the domain of F compose G. Okay.
Okay, sir.
So, okay, if you solve the activity question, take
Yes,
this
sir.
one. Okay. But for your question, whatever you have asked, okay, we'll
Yes, sir.
try to do it
By these above 2 points.
2 points, right?
Yes, sir.
Yeah. So, so now tell me what is F compose G?
F of G is 2x by 3 minus x.
2x by
3 minus x.
3 minus x. Okay. So one thing is clear. Can you tell me? So 3 is not inside the domain of
F of G.
Right? It's clear, right? Because this expression itself is not defined at 3, right?
Yes, sir.
So first thing is you try to find out the domain for this expression. Okay.
Okay,
So
sir.
this is precisely what? R minus 3, right?
Right, sir.
Then you try to consider these two, try to remove these two sets, okay, from this R minus 3. Okay. So next thing what you can do, come to this first point. If X is not inside the domain of G, then X cannot be inside the domain of F compose G. That means 0. So 0 is not inside the domain of G, right?
Yes, sir.
That means 0 also cannot be inside the domain of F compose. That
F
means
composition.
I'll get a even larger set, right? 3, 0, right?
Right, sir.
Next, I have to enlarge my set by considering this second point. So I have to find all such X such that G of X is not inside the domain of X, right?
Right, sir.
So what is domain of X? What is domain of?
All real numbers.
No, all. How come this can be all real?
Or F is equal real numbers except 1.
1, correct. So this is R minus 1. So what is this set? So this set basically say I need to find all such X, right? Such that G of X is not inside the domain of X, right?
All such X.
Such that G of X is not inside the domain of X.
Right, sir.
So that means there is only one element which is not inside the domain of F, right?
Yes, sir.
So I need to find all such X, right? Such that G of X is 1, right?
Right, sir.
So what is G of X?
3 by X.
3 by X, right?
Yes, sir.
That means X is what?
3.
So there is only one X. Okay. So this set X such that G of X is not inside domain of F. In this case, this set is 3, right?
Right, sir.
So then I have to exclude this as well, right? And
Right,
I have already excluded that. Okay, so I don't have to exclude it again.
Okay, sir. Sir, if you
So-
slide down.
So this is the domain of this function.
Yes,
Yeah.
sir.
If you only considering these two cases, okay.
Yes, sir.
But if you consider this one, then what you will get? R minus 0, 1, 3. Right. If you consider this point.
Yes, sir.
Well,
Suppose in domain of F we have R minus 1, 2, and 3. Suppose. And so we have to compute 3 by X is equal to 2, and then we get a 6 as well.
yes, sure.
Right, sir?
Yeah, suppose your domain of F, instead of this, suppose your domain of F is 1 and 2 and 3, right? So
Right,
then
sir.
you have to consider 3 separate cases. X such that G of X is 1,
G of X
is
is equal to 2.
2,
G of X is equal to 3.
3.
Okay, sir.
And here you will get 3. Here you will
We
get
get
maybe
6,
3.
6 and 9.
No, not is it 6? Yeah, probably. What G of X is
No,
what?
is 3 by 2.
3 by 2. Yeah, 3 by 2. Here I guess 1.
1.
Okay, so you have to do it according.
Okay, sir. Thank you, sir.
Mhm. Okay, now I will take your doubt. If you have any doubt, just tell me. Okay,
There is a
Mhm.
question
can I
in
ask, sir?
quiz 1, sir.
quiz 1 now, not today.
Okay,
maybe
okay, sir.
next session you can ask. Okay,
Okay, sir.
so already.
Sir, can I ask now, sir?
Mhm. Yes, please ask.
Yeah, sir, actually my doubt is about how to graph a particular function here. I mean, I've watched the video where Professor Nilesh graphs this. I watched it, but I couldn't understand it. He actually compares it with e to the power of x. I have the function right now. Can you just help me how to get
If
a
you have
graph?
some exponential function,
Yeah, it is an exponential function. Yes,
But
it is an
in general, I certainly there is no particular method to draw
I'm getting confused with the signs. I mean, when the coefficient is having a minus sign and when the exponent is having a minus sign, how to graph it properly. If you could note down the function, you will get my point clearly. What I'm trying to say is, suppose R of t is equal to 50 minus
50
minus 100 times e 100 times into e to the power of minus 0.2 t, that after 2 it's t. So professor actually compares this with e power x, meaning he has the knowledge of the graph of e power x, and based on that he graphs this one. I didn't get it properly after seeing that also.
Okay, again it's basically you are probably you have to what in some sense okay, so
sir, actually professor, he made the graph of e of x and then he made the reflection.
Yes, exactly. I didn't understand
and
when
then
was the reflection happening.
And then he flipped it with the x-axis, and then he like 50 units he shift
moved
the
50
curve
50
up.
units
see
above.
the
Yes,
thing is
yes.
okay, so see the thing is the only thing you need to do, you need to draw the graph of this one. Okay, after that it's basically it's easy. Okay, there is nothing. Once you know see, if you know the graph of x, right, suppose you have a function f of x equal to x, right? What is this function? What is the graph of this function f of x equal to x?
It's a straight line, sir.
This is the increasing function, just like up to what?
Okay, it's
Yes,
basically
sir, like
passes
this
through
only,
0.
yeah.
Okay. Now you want to draw the graph of 2x.
Little inclined towards y.
So right, because here if you are getting 1, so at 1 you are getting 1, right? Here, so here what you should get? At 1 you should get 2, right?
Yes.
Yes, sir.
And here if you are getting okay 1 you are getting -1, then you should get -2. Okay, so this is basically it's sort of multiplying, you are just multiplying or in some sense scaling, right? So this is basically 2x, right? So once you know 2x, then what you need to do? You need to draw this 2x plus 4. What you need to do? You need to shift this graph of 2x, okay, by some 4 units, right? Such that whatever if you shift this graph of 2x by 4 units, then you will get a parallel line. Okay, maybe I have drawn it badly. Okay. You will draw a parallel line, and this basically passes through 0,4. Right? So this is okay. This is sort of very easy. Okay. So for example, you take in some sense you take what? E to the power t, right? E to the power t. So what is the graph of e to the power t?
It's a curve, sir.
Can it
goes up as x tends to infinity. E to the power of x also goes to infinity.
Right. This is the graph of e power t. What is the graph of e power? So what actually we have here? As I said, the main object for you to draw this function, right?
Yes, sir.
E power minus 0 t, right? Or in some sense, which is same as e power 0 t of minus t, right?
Yes, sir.
So what will be the graph of e power minus t?
It's a reflection along the y-axis.
Yeah.
Same.
This one, right?
Yeah, sir, a small clarification here. So when we are changing the sign of the exponent, we are reflecting over it over the y-axis, right, sir?
Not y. Is it no? I guess you are. No. Yeah. Correct. You are when you are basically changing the sign. Yeah. So this case you will get this one. Yeah, with respect to y-axis. Correct. Yeah. Yeah. So the next thing is, so this is your graph of what? E power minus t, right?
Right, sir.
So next thing, what you need to do, you need to draw the graph of e power 0.02 minus t.
Just
Okay.
0.2.
So the thing actually, the difference is what is the difference here? So as you can see, so suppose you take the e to the power t, right? Whatever you are getting, so if you consider at t equal to, let's say 100, right? What you are getting here? You are getting
e to the power minus 100, which is
sorry, minus 100. T equal to minus 100. What you are getting? You are
e to the
getting
power of 100.
e power getting 100, right? You are getting a huge number, right?
Yes, sir.
But here the problem is you have scaling here, right? So at 100, what you will get? Minus 100. You will get e to the power
minus 100. E to the power of 2. Yeah.
2. It's really small, right?
Yes, sir.
So the growth here in this side, okay, in this side, the growth is very less, right? In the negative side, right? If e to the power minus t is going like this, then probably e to the power 0.02 minus t, it will very less, okay, very less. It will grow very badly.
It will be closer to the x-axis when it's
It's certainly it's not. This is not the case. Obviously you will get 0, but whatever it is, I'll come to the right hand side.
I understand the point, sir. Yeah.
Yeah, it will grow very badly. Okay. So next you come to this left hand side, right? Sorry, right hand side. Suppose you take t to the power. Now you take t equals to 100, right? So then what you are getting in this side, you are getting e to the
minus
power
100. Yeah.
It's really small, right? It's 1 by
1 by e to the power of 100.
100, right?
Very.
But here what is this? E to the minus 2, right? Which is 1 by e to the power minus 2. 1 by e to the power 2.
2. Yeah.
And again, both are small, right? Both are small number, but this is much more smaller than this one, right?
Yeah.
This 1 by e to the power 100 is much more smaller than this one, right?
Right, sir.
So then in this part, it is slightly bigger. Okay. It will decay later. Okay. Getting my point?
Yeah, it is decreasing on the right side, and on the left side, it's increasing.
No. Yeah, in both the sides, okay. Just a minute. See what actually I am trying to say. This is the graph of e to the power t, right? This is the graph of e to the power t.
Right. Yes, sir.
But for the case of e to the power 0. Sorry, this is minus t, minus 0.0 t. So this will be more or less like this. So it will be above this one. Both will go towards 0, but it will always lie above this one, the graph of e to the power minus t.
So what you're trying to tell me is that since the coefficient of e to the power of minus 0.2t in the exponent coefficient is much smaller than the exponent, and minus 1 is lesser than minus 0.02. That's the reason e to the power of minus 0.02 goes above e to the power.
Yeah, that is what we checked, right? When we took t to the power minus t to the power t equals to minus 100, okay, then this is really large.
Yeah, it is really large.
And this is
very small. Yeah.
So, but it acts differently in your positive side, right? When t equals to 100, this is really small. Okay, this is really small. This is also small. Okay, but still this is bigger than this one.
Yeah, it is still greater.
That's why, as you can see, it's coming above this one. Okay, so this graph of e to the power minus 0.02 in this side, actually it's actually coming above of e to the power minus 2. Okay, whereas in this side it's coming below of this e to the power minus t.
Okay, right. Yeah.
And next, it's basically it's your multiplication and whatever
the intercepts and the rest.
Yeah, translation. You just need to translate it. Okay, just like you have done it for this function. Okay, x plus 2x plus 4. That is how you do it. So
okay, sir.
So again, like you will basically, if you take maybe some 2 times e to the power minus 0.02. So at x, if you are getting a, okay, for this function at x you will get 2a. Okay, that is the only difference. Okay, maybe you'll get something like this. Okay, if you consider this.
Okay, so what you're trying to tell me is that if the coefficient of e, if it's in having a positive sign, then it will be above, or it will go if it's having a negative sign, it will go below, right? The coefficient of e, not the exponent. If the coefficient is positive, then it will go upward. The curve will be upward.
If it is negative,
then it will go downward.
Yeah, it's here to 2a, right? It's a here, right? Then it will come to minus 2.
Okay.
This.
Right. If it's plus,
then,
it will go up.
Yeah, then probably it will go like this.
Right.
Yeah.
Okay. Yes, sir.
Again, it's not accurate. You can check.
Completely understand. Yeah. Sir, the coefficient part, not the coefficient, the constant part, 50. How do we, after adjusting this, where do we find the 50 mean? The 50 is positive.
What you are doing actually, you are adding 50, right?
Yeah.
So now you have minus 2, right? So you should add now so the image, so you have now you at x, right? You are getting minus 2a, right? If you add 50, then what you will get? Instead of minus 2, you will get 50.
Yes.
Minus 2, right?
Right.
So whenever this function will give you, so there is a point for which there is a x, right? There is a x for which you will get 50, right?
Yes.
For this function, let's say this function. Okay. So suppose you have a point here, let's say b, for which you are getting 50, right?
Right.
No, probably.
Sir, I think that 50 is the y-intercept, right?
No,
the curve will.
What I'm saying, for a point B, you will get minus 50 because the graph is basically below of x-axis, right?
Right.
So at
Okay.
some point you will get minus 50, right? At some B, right?
Okay.
And
Then it will hit the
then,
x-axis.
yeah. So then if you compute f of B, right? Okay, not f of B. Suppose this new function, 50 minus that function. So at that point you will get 0, right? So
Right.
then in that
Once
case,
we
it will-
hit the 0, we are
yeah, then basically at this point you will get the
x-intercept. Yeah.
It will basically hit the x-axis. Then accordingly you have to adjust. Okay, so how you have to see? So here actually you are getting this x equal to y equal to 0 as your asymptote, right?
Yeah.
Right. So if you add 50 to this function, then probably will get y equal to 50 as your
y-intercept. Yeah.
not y-intercept, your asymptote. Okay, y equal to 50 as your asymptote. So this is x-axis. Now this
Right.
x-axis is your asymptote, right? You are shifting the curve by
Yes.
50 units, right? So what I'm basically saying, this is your curve, right? Okay.
Right.
So if you increase the curve by 50 units, right? So you should get some curve like this, right?
Yes, sir.
So then this y equal to 50 is
Will become an
precisely your
asymptote.
asymptote.
Horizontal asymptote.
Yes, horizontal asymptote. Got it now?
Got it, sir.
Yeah.
Thank you, sir.
Thanks.
Thank you so much.
Okay, any other questions?
Sir, the session is over, right? We can leave now.
Yeah, probably. If there is no question, then you can leave.
Thank you so much.
Yeah, thanks. Okay, I guess there is no other question. I'll stop the session. Okay.
Thank you for your time, sir.
Yes, thank you all.
Yes, sir. Thank you for your time.